Hello everybody, this is the seventh video clip for chapter 2, and today we are going to learn like how to find a derivative of a complicated function. For example, what we have learned, actually it is a derivative of x raised to the power r, which is r x raised to the power r minus 1. However, if we encounter the problem, oh, don't forget that this r can be any real number, right? If we just encounter this kind of problem, okay, it is not a square root of x, but it becomes a square root of x cubed plus 1, then we don't know how we go, right? We don't really know what to do. So we are going to introduce you another rule that will help you finding a derivative of this kind of function. And this kind of function, sometimes we can see it as a two simple function composite. Okay, so for example, this one we can say that, hey, this is so let's say that here this is the capital F, okay, as x cubed plus 1, okay, the one inside, and then the capital G, okay, it can be a square root of x, okay, the one outside. You see, you just look at the thing, the whole thing inside as one, a single term, okay, x. So you have a gx as a square root of x, okay, and then this one becomes a g composite capital F, right? Because here it is a g of f of x. Remember on the um, on your high school, okay? So here it is a g of x cubed plus 1. So it means that anything as an input here, you insert it under the square root, right? So we have it this way, okay? So, and this one is called a composite function. And then how are we going to find the derivative of a composite function? We have this formula here, okay, this formula right here. The is saying that if we have a composite function of f or g, okay, then to find a derivative, okay, to find a derivative of a composite function, it means that you find a derivative of the one outside, okay. So this one is the derivative of only the f, and then after that you replace your x by gx, and then multiply by a derivative of the inside, okay. So this one usually we call a derivative of the inside, okay, multiply. Okay, so you need to look at it carefully. Which one is your inside? Which one is your outside? Okay. Or sometimes by using this notation, okay, we can say that, hey, if your y is a f of u, and this one inside your u is a g of x, then to find a dy by dx, okay, you may look at it, roughly speaking, again as a fraction. So it will be a derivative of y with respect to u, okay. So this one, it means that uh, the variable under consideration here is u, okay. So the variable is the u, but this one, a derivative of u with respect to x, so it means that the a variable under consideration is the x, okay. And roughly speaking, if you look at it as a fraction notation, you may see that, hey, this one is look like the du cancelled, and then you end up with dy by dx that you need on the left hand side, you see, okay. So we can either use this formula or that formula. However, the one that I just wrote it write down, uh, it depends on GOF. So it just the other way around, that if we talk about the GOF of x, so it means that you find a derivative of the one outside, which is the g now, and then you replace your x by a capital F of x, and then multiply a derivative of the one inside, which is the f prime, okay. So I mean the f and the g is just a parameter, okay, so it can change into any kind of functions, okay. So here it means that to find your f prime, okay, to find your f prime, it means that you are going to find your g prime first, okay. So what is your g prime from here? from here, your g prime is just simply 1/2 x raised to the power negative 1/2. Is that correct? And then your f prime, this is what you need as well, is 3x squared plus 0. Okay, so by using the chain rule, okay, so the chain rule says that this one will be a g prime of f of x multiplied by f prime x. Then what does this mean? So it means that it will be g prime of your f of x, which is x cubed plus 1 multiplied by f prime of x. Okay, and actually your f prime is already given to be, is already found to be x 3x squared, right? So this one it will be a square root of sorry, not a square root, but it will be what? Because here is a g prime, right? So you need to insert it in this x. So we have 1/2 and x cubed plus 1 raised to the power negative 1/2 multiplied by 3x squared. Okay, or you can rewrite it into 3x squared over 2 and then square root of x cubed plus 1. Okay, we all right? And on the other hand, you may look at it this way. Okay, the chain rule, the chain rule. Let's look at your f again. This one is a what? X cubed plus 1 raised to the power 1/2, right? Right. So you look at it this way, that here is the one inside, okay, and the whole thing is your outside. Okay, so it means that to find your f prime, it is a derivative of the outside. Okay, look and regard the inside as the x. Okay, so it look like you have x raised to the power 1/2. So you have what? 1/2 kicked down, and then the inside raised to the power negative 1/2, right? Okay, so you put the inside here, this one, you see, and then multiply by a derivative of the inside, derivative of the one inside. Okay, so which will give you what? 3x squared plus 0. So you end up with the same thing, which is 3x squared over 2 square root of x cubed plus 1. Okay, so this is like how we usually work with the chain rule. Okay, if we just encounter this kind of complicated function. Okay, however, there'll be another way of asking you to use the chain rule, and you may need to look at this kind of formula. Okay, we will see that kind of problem later on. Okay, so let us use this kind of idea to work with some other problem first. Okay, so let's for example, let's look at this one. You see, here is the one inside, and then the whole thing is the outside, right? So this one, it means that it seems that you have the inside square, is it? Okay, so what is the derivative of that x square? So you just regard it as x square. What is the derivative of x square? It becomes 2, and then the inside raised to the power 2 minus 1, right? And then multiply by a derivative of the inside, which is a derivative of sine, becomes a what? Cosine. Okay, so this one, a derivative, you end up with 2 sine x cosine x. We get, but this one here is a different, a total different. Okay, here you see this is the one inside, and this whole thing is the outside function. So actually, for this problem, you have side of a box, side of an inside. So you are thinking of side of x. So to find a derivative of sine x, it becomes cosine of the inside. Okay, you see, cosine of the inside. And then a derivative of the inside multiply. So the inside right now is x squared. So a derivative of x squared, it is 2x. Okay, or usually we rewrite it as a 2x cosine of x squared. Okay, this one, look at it this way carefully. Okay, here is the inside, there is the outside. Okay, so it means that you are going to regard this problem as e raised to the power a box or e raised to the power x. Okay, so that is the outside function. Okay, a big picture. So it means that a derivative of e, it is e to the x itself, right? So right now it is e to the one inside again, and then multiplied by a derivative of the inside. It has to be multiplied. So you write it carefully, okay? So the one multiplied, it will be on the same line as e, okay? Not multiply with the exponential, the exponent, okay? So a derivative of tangent, it is a secant square, okay? So this one becomes like e to the tangent of x multiplied by a secant square of x. However, if you look at this one, here is the one inside, there is the one outside. So the outside function, the major one is a tangent, okay? So you need to look at it as a big picture as a tangent of x, okay? So a derivative of a tangent, it becomes a what? It becomes a secant square and the inside function, you see? And then you find a derivative of the one inside, which is a derivative of e to the x. It becomes e to the x again, okay? Or usually we just write it as e to the x and then secant square of e to the x, okay? Now, look at it this way carefully. This one at the beginning, you may see that, hey, you got two functions divided each other, right? The top is your 1, the bottom is your 2 plus a secant. However, this one can be regarded the other way around as 2 plus secant of x raised to the power negative 1, right? The whole thing, okay? So it means that here is your inside, okay? And then the whole thing is your outside. So you will look at it as x raised to the power negative 1. Okay, x raised to the power negative 1. So what is the derivative of that x raised to the power negative 1? It will be negative 1. And then the inside raised to the power negative 2, right? And the inside is this one, this function. Okay? And then a derivative of the inside multiply. So a derivative of 2 is 0. And a secant becomes secant x tangent of x. Okay? So this one you can rewrite it into a secant of x, tangent of x, and then over 2 plus secant of x squared. We get, okay. However, if you look at this one, here is what inside, there is your big picture outside. So it means that you will look at it as secant of x, okay. So what is the derivative of a secant of x? It will be secant of the one inside and then tangent of the one inside. So let me move it a little bit. Okay. So it will be equals to this one and then the one inside, right? Okay. Multiply by a derivative. So here is the inside. Here's the inside, and then multiply by a derivative of the inside function, which is derivative of 0 and derivative of x raised to the power 1, right? 1 over x. So we have negative 1, x raised to the power negative 2. Okay, or you can rewrite it as negative secant of 2 plus 1 over x, tangent of 2 plus 1 over x, and then over x squared. Okay, don't forget this negative here is already there. Okay, so here is like how we use the chain rule, and how we look at it. Okay, so we see a big picture first and then try to dig in the one inside. Okay, so here's another one that you may use it several times. Okay, and actually we did use it already. It's so-called a power rule combined with the chain rule. Okay, so if your f is simply x raised upon r, then we already know that f prime is r x raised upon r minus 1. So if your f or g of x is g raised upon r, so here is the one inside, right? And there is the one outside. Okay, so again, a big picture is x raised upon r. So it means that a derivative of this composite function, it will be a derivative of gx raised upon r. So we kick down this r, we lower the power by 1, and then you multiply by a derivative of the inside function. Okay, or you can write it this way simply, a derivative of u to the r, it is r u raised upon r minus 1 du by dx. Okay, so usually in terms of formula, okay, like a formula sheet, we are going to see the way they write a formula this way, okay, attached with chain rule already. Okay, and for example, uh, uh, let me just write down first, okay? For example, if we talking about a derivative of e raised upon u, it become e itself and then du by dx, okay? Or a derivative of sine u, it becomes a what? Cosine u du by dx. A derivative of tangent of u, it becomes a what? Secant square u multiplied by du by dx. A derivative of secant of u, it becomes secant of u tangent of u du by dx. Okay, so you notice that each one of them will be a derivative with respect to x, but here the variable is u. Okay, so that's why we need to attach with the du by dx. But if a variable happen to be x already, this one dx by dx becomes what? Becomes 1, remember? And then another 3 is cosine, right? Which is negative. Sorry, this is u. So it will be negative sine u du by dx. Derivative of cotangent. So it will be negative cosecant square u du by dx. And a derivative of cosecant, it will be negative cosecant cotangent and then du by dx. Okay, something like this. So this is like the way we write the formula sheet, okay, and attached with chain rule. So let's go back to this one. Okay, we are going to use a power rule together with the chain rule. Okay, so here it look like your g, right? And then your r is 6. So it means that your y prime, it will be 6. And then this whole thing copy, okay? Rest of power 6 minus 1, which is 5. And then a derivative of the inside. We okay? And then for a derivative of the inside, this time, you need to use the quotient rule. So you got a 6 and then 10 minus x fourth. So this one, you just copy. This is, sorry, this is sine. Okay, you just copy it down. But then right now, your work, okay, move to this one to find a derivative. So it will be a bottom, derivative of the top minus the top, derivative of the bottom over your bottom square. Okay, and then you can leave it like that. No need to really simplify. Okay, that will be good enough. Okay, how about this one? How about this one? This one at the beginning, you see that the thing, you got two functions multiplying. So you need to use a product rule first at the beginning. So your y prime, it becomes a what? The first, right? And then derivative of the second plus the second, and then derivative of the first. Let me write down here, okay? Sorry. Okay, this is multiply, okay? So now you just copy this one down, right? And then what is the derivative of this one? You just look at it as your gx raised to the power 4, right? Okay, so it becomes 4x cubed 3x minus 1 cubed, and then multiply the derivative of the inside, which will give you 3x squared plus 3. Okay, so this is all your what should I say, the first one here. Okay, and then you are going to add with that second term. Okay, this one copy, and then a derivative of this one right here, you just kick down the pi, and then this one 2x plus 5 pi minus 1, and a derivative of the one inside, which is 2 and 0, right? Okay, and again you can leave your answer like that, no need to really simplify. Okay, we good. So this is your chain rule, the y prime. Okay. Now let's look at this one. Let's look at this one carefully. Okay, so here is another thing that you may need to see that, hey, it's a little bit complicated. Okay, so now this one, okay, from the formula you have what, gx raised to the power r. If this is your f, then your f prime, it is r gx raised to the power r minus 1 multiplied by g prime. But this one, don't just stick with the g. This one here is your inside, there is your r, the 8. Okay, here's your r. So it means that to find your f prime, it will be kick down the r, and then this one copy raised to the power r minus 1, and a derivative of the one inside, which is 0 and g prime. Okay, because your g, we don't know what it is. And if you want to find your f prime at 2, you just replace each and every x by 2. This is g prime at 2, right? Because 0 it just added, it just g prime, right? So we have 8 pi plus 3, 7, and then negative 4, or negative 32 pi plus 3 raised to the power 7. Okay, so that will be your f prime at 2. This one as well, what we have in the formula is that a formula for the chain rule saying that if you have your FOG prime, right, it will be f prime of gx multiplied by g prime x. However, for this one, we can rewrite a little bit, okay, into like f of something, okay, and then what should we do? Prime, okay, find the derivative, right? So it would be that capital F gx, because this one, it is actually the same as what? FOG, right? Okay, and then multiply by g prime, okay? So it means that this one inside already your capital G, okay? Okay, so it means that your capital G is x squared and then x raised to the power negative 1/2, okay, because it is at the bottom, right? So here, to find your y prime, it is what? Using a formula, it will be f prime, and then your g, and then a derivative of the one inside. Okay, here, it is this one inside. Okay, so it means that right now your work, I mean the task that you need to do moving to a derivative of this function. So here it just copy, right? You just copy. And then this one, a derivative of x squared is 2x, and this one become negative 1/2 x raised to the power negative 3/2. But then you need to find your y prime at a particular x equals to 1. So as you replace your x by 1, so this one becomes 1 square minus 1. And then this is a 2 plus 1/2, right? But then your f prime at 0 is given. Is it the 2 plus 1/2 will be what? 5/2. So here is 2 and then 5/2 because your f prime at 0 is given there. So you got a 5 as your derivative of this function. Are we okay? So you really need to look at it carefully, which one is which, so that we look at, okay, which one is the outside, which one is the inside, and what kind of formula that we are going to apply, okay? So for example, this one is not that difficult, right? You can see already that here is your G, there is your R. So it means that to find the tangent line to the curve, you need your y prime at 0. So before finding the y prime at 0, we find a y prime at any point x first. So you kick down the R, okay? And then find a derivative of the inside. So we can write this way first. Okay, so here becomes 2e to the x, 3x, and secant of x copy. This one, a derivative of e is just e, a derivative of 3x is 3x, and the secant becomes secant and tangent. Okay, so here's your y prime. So it means that your y prime at 0 becomes a what? 2, e to the 0 is 1, this is 0, secant 0 is 1, and then e to the 0 is 1 minus 3, and then secant of 0 is 1, but tangent of 0 is 0. So you got what? 4, right? And negative 2, so you have negative 8, is it? But then the tangent line, because you need the equation, okay, it will be y minus the point that passing through. So if your x is 0, your y at 0 becomes what? 1, and then 0, and then 1 square, which is what? 4, right? So it is y minus 4 equals to a slope x minus 0, or you can say that it is y equals to negative x plus 4 as a result. Okay, so this is how you find a tangent line. Okay, now if you go a little bit further, you can actually use the chain rule to find a derivative of some other functions. Okay, for example, the exponential in terms of a to the x instead of e to the x. Okay, at the beginning we got this one, right? This is what we have got. Okay, a derivative of e to the x, it's just e to the x itself. Okay, but now what if instead of e we have a? Okay, so we know that if your a is positive and is not 1, we can write your a as e raised to the power log a. So it means that e to the x is the same as e raised to the power log a multiplied by x. So here is look like e to the u, right? Here is your u. Okay, so a derivative of e to the u, it is e to the u du by dx, right? So here a derivative of e to the u become e to the u itself, and then a derivative of u. Okay, and a derivative of a constant multiplied by x, it's just a constant multiplied by 1, right? And this one, okay, we just rewrite it as a to the x again. So it means that if you look at a derivative of a to the x, if your a is positive and is not 1, it becomes a to the x multiplied by log of a. If it happened to be e, log of e just happened to be what? To be 1. So that's why a derivative of e to the x is just e to the x log of e, but this is 1. So e to the x itself, okay? Or Again, this one you can look at it this way, that if you got a to the u, it becomes a to the u log a multiplied by du by dx as well, if you attach it with a chain rule. Okay, so now let's look at the first problem. You see here, you see here is the u, there is your a is 2, so it becomes a what? It becomes a to the u. You see, we're using this formula, right? Log of a, don't forget, and then a derivative of the one inside, which is your u. So you got 2 sine of x log of 2, and a derivative of sine become cosine. Okay, and usually we will write it as 2 sine x cosine x, and then multiply by log of 2. Okay, and how about this one? This one you may say that, hey, this look like 3x minus plus x cubed raised to the power negative 1, right? So you look at it as gx raised to the power r. So using the chain rule, this one kick down, and then this inside function raised to the power negative 2, and a derivative of the one inside. Are we okay? Okay. So here is negative 1, 3x, x cubed, and the derivative of 3 to the x, we simply use this one with your a is 3, so it's 3 to the x log of 3 plus 3x squared, or you can rewrite it as 3 to the x and then 3x squared over this one square. Okay, okay, all right, so let us try a little more complicated. Okay, it will be several insights, okay, that you may need to see. Okay, so you are going to like uh, peel it layer by layer. For example, this one, okay, so it means that your y prime, you look at it this way, you see that you got this one as a major thing, right? It is like u raised to the power 12. So you kick down the 12, and then you have this one raised to the power 11, and then a derivative of the first layer, okay, a derivative of sine. So the next layer you see side of something. So it is again, don't worry, it is a derivative of sine, right? So you still have a cosine, okay, of that thing. But then this one is another inside. So you need to find a derivative of the inside because it's not an x itself, okay? And this one, don't forget that it is x raised to the power 1/2, right? So a derivative becomes what? This one, square root of x, 11 cosine of square root of x, and then 1/2 square root of x. Or you can simplify it to 6, and then sine of square root x raised to the power 11 cosine square root of x over a square root of x, right? Because this 2 and that 12 can cube. Okay, so you see you got several inside. You need to look at it carefully. Look at this one. The major function outside is a cotangent. So your y prime is a derivative of the cotangent, which is negative what? Uh, uh, Cotangent, it will be a cosecant square. Is it right? And then a derivative of this one inside. Okay. And if you look at this one inside, a major function is 3 raised to the power u. You see, so it becomes a what? Negative cosecant square of this one called p, and then a derivative of 3 to the u will be 3 to the u log of 3, and then derivative of this one inside. Okay, and this is just 2x, right? So we can say that this is negative 2x, okay, here, okay, with the negative, and then cosecant of 3x square, 3x square log of 3. Okay. Now, look at this one. A major one is a secant square. You see, secant square. So a derivative becomes a what? Kick down the 2, the secant raised to the power 1, right? And then a derivative of the inside, which is a derivative of a secant. Okay, you see this is another inside, but the major one is a secant. So now it is this one copy, and we actually don't really need a parenthesis. Okay, pi square, and then a derivative of secant, it will be a secant, right? And a tangent. Okay, we need to move a little bit again. Okay, a secant and a tangent. Oh, let me just move it here. Okay, so here is a tangent of 6x pi square, and then a derivative of this one inside. Okay, and what is the derivative of this one? The last one inside. This one becomes what? 6x log of 6 plus 0, right? Because don't forget that a pi square is a constant. Okay, so here you end up with what? So let me do it this way. We cannot write down. So let me just do it this way, that you have 2 secant of 6x. Oh, but you got this one, right? So it means you got secant square pi square, tangent of 6x pi square, and this one 6x log of 6. Okay, so this is this problem. Okay, so let's look at the next problem, number D. So let me just write down here. So for your D, the problem is e raised to the power cosine 4 raised to the power x. Right? Okay, so it means that the major function is the e. Okay, so your y prime becomes just e to the u, and then a derivative of the u. Now a major function is just a cosine, so this one, don't forget to copy the one that you already done, right? A derivative of cosine become a sine, and then a derivative of inside. So here you have negative e, okay, sine, and then a derivative of 4 to the x become 4 to the x log of 4, and then we are done because right now it's already the x. You see? So here's the last one. All right. So if you have time, please do exercise 3.4, number 1 to 55 and 68 to 78, okay, to practice the way you find a derivative using the chain rule, and also like using all this kind of formula that we have learned. Okay, so we are going to stop this video clip right here, and then we still have like some other techniques finding a derivative that we are going to go over with you in the next video clip. So we'll see you then. Bye bye.